Let's try another inductive proof. Step number 1, we let n equal 1. On the left, we're testing -4 times 1 plus 12. Is that then equal to -2 times 1 times 1 minus 5? We have -4 plus 12, which is 8 on the left, and I need question marks over my equal sign because I'm testing this. Do we have -2 times 4 there, which is -4? Yes, we do. When you substitute n equals 1, this is a true statement. Step number 2, we are going to assume that this is true for n equals k. So I will rewrite my formula up above and change out these n's for k's. Assume that 8 plus 4 plus 0 plus ... plus parentheses -4k plus 12. Assume that that is equal to -2k times k minus 5. We are assuming this to be true. We don't doubt it. Based upon this now, we want to show that s sub k plus 1, when you add on the k plus first term, that this formula should work. In other words, where these k's are, we should have k plus 1s. So we want to show that this is going to equal -2 times k plus 1 times k plus 1 minus 5. Okay, simplifying this, we have -2 times k plus 1 times k minus 4. Now let's actually go and find s sub k plus 1 manually. S sub k plus 1 equals, well, we're taking the series that we had, 8 plus 4 plus 0 plus ... plus the -4k plus 12. That's the sum of the first k terms, and we are now adding on the k plus first term, which is the term before it with k plus 1 substituted in instead of k. So plus -4 times k plus 1 plus 12. Now, we've assumed in this first line that the sum of the first k terms is -2k times k minus 5. So I can take the sum of those first k terms that we have on this bottom line and turn that into -2k times k minus 5, and then add on this next term over here to the right, which is -4k minus 4 plus 12. Now let's do the algebra here and simplify this expression. I'm going to distribute here. We will have equals -2k squared plus 10k minus 4k plus 8. Combining like terms, we have -2k squared plus 6k plus 8. I'm now going to factor out a -2 to have k squared minus 3k minus 4, and this will then factor to -2 times k plus 1 times k minus 4. Now let's compare that. Let me see if I can get both of these on the screen at the same time. Yes, I can. These are both equal to each other, and that means we have then finished our proof and shown that this is true using induction rather than deduction. In this problem, we want to prove inductively again that the sum of this series is equal to 4n squared. So step number 1, we let n equal 1. And the left side of this formula, when substituted in, gives us 8 times 1 minus 4. Is that question mark equal to 4 times 1 squared? Well, the left side is 8 minus 4, which is 4. And the right side is 4 times 1, which is 4. So yes, for step 1, we're good. Step number 2 in the inductive proof process is to assume that this statement is true for the first k terms. So we will rewrite the formula, changing out the n's for k's. So 4 plus 12 plus 20 plus plus 8k minus 4 is equal to 4k squared. And then we want to show that the sum is going to work when we substitute it in k plus 1. So show that the sum of the first k plus first terms is equal to 4 times k plus 1 squared. When you go up to the kth term, it adds up to 4k squared. So when you go up to the k plus first term, it should add up to 4 times k plus 1 squared, changing the formula so that each k becomes a k plus 1. Now, let's do this another way. If we take s sub k plus 1 and add them up manually, 4 plus 12 plus 20 plus plus our 8k minus 4, that's the sum of the first k terms, which we have already shown to equal 4k squared. We are going to now add on the k plus first term, which is going to be 8 times k plus 1 minus 4. 8 times k plus 1 minus 4. Adding that on the next line, we're adding 8k plus 8 minus 4. And continuing along here, we have 4k squared plus 8k plus 4. Let us simplify this by factoring out of 4 to then have k squared plus 2k plus 1. And that factors into 4 times k plus 1 squared, which is the same as the sum of the first k terms that we had up above. And that finishes our proof.